A very warm welcome to all my dear students. So let's get started with chapter 1 of class 12. Before starting the chapter, I would just like you to give an overview of the CBSE syllabus. So this is the syllabus for class 12. Here you can see that 70 marks is your theory and 30 marks is your practical. There are 4 different units. The first unit is your data handling, which carries 30 marks. The second unit is your basic software engineering, which carries 15 marks. The third is data management 2, which is of 15 marks. And the last is society, law and ethics, which carries 10 marks. So these all sum up to 70 marks and the practical of 30, which again summed up to 100 marks. So let's see the unit 1. So the chapter which we'll be doing will be covering this part of the unit, that is Numpy, 1D array, 2D arrays, slices, joins, subsets, arithmetic operations on 2D arrays, covariance, correlation and linear regression. So without further ado, let's get started with this chapter. So this chapter comprises of explanation of what is a Numpy array. So Numpy array is the array which uses Numpy module, and it is a group of homogeneous element. Like if we want to store the marks of the students of subject type B, or we want to just store the choice of ice creams liked by the students, etc. It can be created in 2 forms, in form of 1D and 2D. Let's talk about 1D array. The Numpy array of 1D is also known as vectors. They have single row or columns only. Like for example, if you want to create a 1D array, you can create it by different methods. So let's see the first method. In this, you can have a list in which there are certain numbers. Now that list can be converted to a NP array by use of method np.array and the name of the list in the argument. Now if you want to print this, you can print it by writing print n1, which is a array of NP type of 1D. The second method is to take directly the list into the argument. We can also access single element of an NP array through indexes. Like for example, it is the same indexing as we had it for string. The index starts from 0, 1, 2, 3 and 4. So if we are printing n2 of 2, it will print 3. And if n2 of 0, then it will print 1. So you can just see how the indexing is done. So let's try it. Let's start with the practice, how to create it. So first of all, we will import Numpy array. Import Numpy as NP. We'll create a list which will comprise of elements, and then we'll convert this list into a NP array. So np dot array, and in the bracket we'll write the name of the list, and after that we will print the list, and then we'll run this and we get the answer, right? So again, this can be done. The second method, what I told you, is directly we can just write the name, directly we can write the list. We don't have to assign it to a variable, and then we'll just and then we can run and see, and we are getting the answer. If you want to access the individual element, we can just write n2 of 1, and can you guess the answer? The answer will be 2. Okay, so this way we can run and see. Let's get back to the chapter. So now how to create a 2D array? So for the 2D array, we need to have the two lists. Okay, so for this we can either have the list as an argument enclosed in a square bracket, or we can assign two lists and then we can pass it as an argument. Okay, so let's create this list. So how we'll do it? We'll do at L1 equals to, let it be 2, 4, 6, and then L2 equals to 3, 6, 9, and then we'll write N2 equals to np dot array, and then round bracket, again the square bracket, and then L1 comma L2. Okay, and then we can print and just run this. So now you can see we have created a 2D array. Now if you want to access an element, so you can access it like this, print n2, and then if I write 0 and then I write 1, so can you guess which will be the element? This is 0 0 0 1 0 2 1 0 1 1 and 1 2, so the answer will be 4. Okay, so this is the numbering of it. This is the indexing part. Now we'll see how do we store the element in a 2D array in a memory. So 2D array, single array is stored in a contiguous memory location, but 2D array can either be stored in row major or column major form. Let's see how do we store array in row major form. This technique stores firstly the first row of the array and then the second row and so forth. Like for example, if you have 2D array like this, like 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is the first row of the array. So the first row will be stored first, then the second row and the third row. So in row majors, the preference is given to the storage mechanism through row wise. Now come to column major implementation of 2D array. This technique stores firstly the first column, then the second column, and then the third column. So if we have an array like 2, 4, 6, 8, 10, 12, 14, 16, 18, then the first row will comprise of the numbers 2, 8, 14, the second one 4, 10, 16, and the third one as 16, 12, and 18. So it is stored in the same way as column wise, that is 2, 8, 14, 4, 10, 16, 6, 12, and 18. Now we'll look into the anatomy of Numpy array. So Numpy arrays are stored in very detailed manner internally for the faster access and processing of data. So one-dimensional array is stored in contiguous memory, and the two-dimension arrays are stored in row major or column major form. The one-dimension array has just one axis, that is axis 0. Two-dimensional arrays have two axes. This one is axis 0 and this is axis 1. So when we talk about top to bottom, it is axis 0, and when we talk about left to right, it is axis 1. Rank. Rank tells us about how many axes does an array have. So the 1D array will have a rank 1 and 2D array will have rank 2. The shape tells us about the number of elements along each axis. So if we talk about this array, the shape is 5 because it has 5 elements. And if we talk about this 2D array, it has how many elements? 12 elements. But it will not write 12. It will write the number of elements along each axis. So there are 3 rows and 4 columns in it, right? Data type. Data type tells us about the type of data that is stored in an array, like example float, int, etc. The item size will tell you about each element in bytes. So how much byte does a single element contain. So we have just taken an example. So we have an array, 2D array, and then we are writing, or we are typing the type and the name of a array. So it gives you numpy nd array. So the type is nd array type. The shape is 2 into 4. So 2 rows and 4 columns. The item size is 4 because int, by default it is int here. So it is item size is 4 and the data type is int 32. Now what are the similarities and dissimilarities between the Python list and the Numpy array? So the very first thing is that once the array is created, we cannot change their size. And the second similarity is that it contains the element of same type, homogeneous type. So if it has the name of the student, so every element will contain the name of the student. If it is the marks of IP of periodic test 1, every element will have a marks. Now what is the dissimilarity? The very first dissimilarity is that NumPy occupies less space than the Python list in terms of memory. And secondly, the NumPy supports vectorization operation. That is, any operation which is performed on each and every element of array, not on the array as a whole. Whereas Python list performs the operation on the array as a whole. Vectorization operation of ND array can be explained by the following example. Like if I have taken a ND array N1 and we add 2 to it, right? And then we print, each and every element will be increased by 2. So you can see here the example. But if we take a list and we add 2 to it, we will get an error. Why? Because list can only concatenate a list. It cannot concatenate int. So this is vectorization. Now let's talk about the data types. So these are various data types that is permissible in the ND array, like Boolean, int. Int has different categories like the default integer, then the int p type, 8-bit, 16-bit, 32-bit and different, 64 and others. These are also floating point number and the complex number, which can comprise as the element of the ND array.